Okay, guys, in this lesson, we are going to learn how to describe a function as either being odd, even, or neither when we are given a graph, a table, or an equation. So the basic definition of an odd and even function are as follows. It all depends if they reflect across the y-axis or the origin. That is all that we are checking for. If a graph reflects across the y-axis, such as the one we see on the left, this is considered to be even. Let's take a look at some ordered pairs. So this reflects across this y-axis. Everything mirrors, each point mirrors one another. So what does that mean? So here we have the ordered pair, -2, 4, and then it mirrors, has a corresponding point of +2, 4. So when we are testing these, we're always going to be testing we're going to put in the x value and its opposite, and then we're going to see what kind of output we get. If our outputs are the same, then it is even. So when outputs are the same, we have an even function. It will be reflecting across the y-axis. Here's another point. So this is 3, 9, and then when I have -3, I get out the same output. Again, it's all about what the output is when I put in a value of x and its opposite. So this is an even function. To be odd, it has to first pass through the origin or go around the origin. So if we have this continuous graph, it will go through the origin. And it will be symmetric about the origin, which means if I rotate this graph 180 degrees, I will get back where I started. Now let's take a look at when we put in a +1 compared to when we put in the -1. So when I put in +1, my output is 1. But on this time, instead of getting out a +1, the same value as we did on even, if we get out opposite values, if our outputs are opposite, then it is odd. It is symmetrical about the origin. Let's take a look at some more examples. Here are examples of functions that are neither odd nor even. And I will say that most functions are neither. So you can see on this one, it is not odd. We do have an odd exponent, but you can see the graph doesn't pass through the origin, and therefore, once we rotate it, we would not end up with what we started. So we have this ordered pair and this ordered pair, and the x values are not even the same. So I really can't even compare these. So when I put in +1, I get -2. And then what we should have is if I put in -1, I should get a +2. And you see that's not the case. So this is neither even nor odd. And I'm only checking for odd because I have an odd exponent. So now let's move on. Here we have an exponent of 2. So let's see if it's even. And we can see that it is not symmetric about the y-axis. On our third one, we have an exponent of 1. So to test to see if it's odd, it doesn't pass through the origin. It's not going to be symmetrical about the origin. So these three are examples of functions that are neither even nor odd. Now let's try some together. We can see this is our quadratic, our parabola, and we're seeing if it is either symmetrical about the origin or symmetric about the y-axis. It is neither. Now we have this linear function. It is passing through the origin. So let's see if we have opposite outcomes. So when x is 2, our output is -1. Now when x is -2, we should get out the opposite of -1, which is +1. So this is odd. The outputs are opposite. the outputs are opposite. So we have an odd function. Here, this is not going through the origin, so we're not even going to test to see if it's odd. To see if it's even, let's just pick a point. Let's just pick this point and see if it mirrors this point. So this time when x is 3, the output is -1. So when x is -3, we should also get out -1, and we do. So this is even. Our outputs are the same. Here's our parabola. It is symmetrical about the y-axis. We can prove this, pick a few points. When we put in +1, we get out 2. When we put in the -1, we also get out 2. We have an even function. This continuous graph is not passing through the origin. It is not going to be odd. It is not symmetrical about the y-axis, so we call it neither. Here we have a cubic. It passes through the origin. It looks like that it is symmetrical about the origin, so let's prove it. So when we put in +1, we get out -1, and when we put in the -1, we should get out the opposite of this -1 here, and we do get a +1. So it is symmetrical about the origin. It rotates around the origin. It reflects about the origin, so we call this odd. We have opposite outcomes. Here we can see that this parabola has shifted up to the left some. It is not symmetrical about the y-axis. Therefore, this is neither. Our cubic this time is shifted up. It's not going to go through the origin. And so we can see this is neither. This parabola is symmetrical about the y-axis. So let's pick 2 points to prove it. We have when x is 2 and when x is -2, we can see that our outcomes are the same. So this is even. Okay, this time we are given a partial of an even function, it says, and we need to see what it looks like on the other side. I'm going to grab a different color. And so here, when we reflect 0.05 about the y-axis, it just lands right back on itself. Then we have this order pair -2, 5. So when we have -2, 5, and we put in +2, we should also get a +5. This point, -3, 6. When I put in +3, I should also get out 6. Then we have -5, 3. When I put in +5, I should also get out 3. And then I have -7, 5. So I should have +7, 5. And this reflects about the y-axis. This time we are given a partial graph that is odd. So let's first start out and we'll do the purple. So this ordered pair is -7, and then I get, so when x is -7, I get out -6. So when I put in +7, I should get out the opposite and have +6. So that's being rotated 180 degrees. Now let's do our yellow one. And so -5, -5. So when I put in the +5, I should get out the opposite of that other outcome. And we have +5. Make that a little bit darker. Okay, now let's do the green dot. So I have -6, -3. So I should have 6, +3. And then the light blue, that's -4, -3. So I should have +4, +3. And then let's do the navy. So -2, -2, and then I should 2, 2. Now notice this graph is not going through the origin, but it is odd. It's not a continuous graph. It's more of a scatter plot. And then we have -3, -1, so I have +3, +1. And there we go.